Let's take a look at the following chart regarding quadratic equations and inequalities. The first row is showing quadratic functions or graphs that have two x-intercepts that break up the x-axis into three parts. If you have a quadratic equation, your solution set will be in curly brackets and will contain the x values of a and b in this case. If we look at the inequality of the parabola opening up, that of f of x is less than 0, we see that the points of the graph in between the values of a and b are below or less than 0. This means our solution set will be the interval of, in parentheses, a comma b. The x values in which the graph of the quadratic function is below the x-axis. We can also see the following inequality of f of x is greater than 0. This means we are looking for the x values in which the graph is above the x-axis. We can see that these two parts of the parabola are above the x-axis, so we need to state that these two intervals as our solution as noted here in the chart. Take a few minutes now to look at the other graph on the same row. You will see that the graph of the parabola opens downward and changes the solutions for the inequalities, but not that of the equation, as the x-intercepts do not change, but the portions of the parabola above or below the x-axis changes. The second row of parabolas illustrate the situation in which the vertex is on the x-axis, in which the graph has only one x-intercept. Notice here that the quadratic equation has a solution set of only one x value. One graph is opening up and the other is opening downward. Let's take a look at the parabola opening upward. For the inequality of f of x is less than 0, we are looking for the portion of the parabola that is below the x-axis. From the graph, we see that there are no portions of the parabola that are below the x-axis, so the solution set is empty, and that is represented by the null space. The inequality of f of x is greater than 0. We are looking for portions of the graph that are above the x-axis. We see that all but the vertex is above the x-axis. The vertex is on the x-axis and not above. Note here that if this was f of x is greater than or equal to 0, the vertex would be included in the solution set, changing it from the two parts shown to all real numbers, or from negative infinity to positive infinity. In the row, the downward parabola result is similar solution sets. We are going to have to pay close attention to what values the inequality is requesting. Finally, let's look at the last row of parabolas. We see here that the parabolas do not touch the x-axis at all. This means that there are no real x-intercepts or solutions for the quadratic equation. But we take a look at the quadratic inequalities, and we see that looking at the upward parabola, we can ask for f of x is less than 0. That means we are looking for parts of the parabola that are below the x-axis. From the graph, we see that there are no parts of the parabola below the x-axis, but we do see that the entire parabola is above the x-axis. So for f of x is greater than 0, the solution set will be for all x values, or all real numbers. In interval notation, we would have to have it from negative infinity to positive infinity. You should be able to see a similar situation for the downward opening parabola in this last row.